Started. Hey everyone, welcome to day 19 of Math 133. Today we're going to cover the Chapter 8 review. I'm going to leave my video off. Last couple of times we had some bandwidth issues, but anyway, the Chapter 8 review starts on page 471, and Chapter 8 is all about the central limit theorem. Um, there's two of them. There's central limit theorem for means and central limit theorem for proportions. And so you're going to want to pay attention when you are using it. Are we looking at means or are we looking at proportions? Okay. And we're going to be using this for chapter 9, chapter 10, and 11. So uh, we didn't really split chapter 9 as two different chapters, one with means, one with proportions. So you just have to pay attention to whether you're trying to measure a mean or a proportion, okay? Usually it'll be pretty obvious. Anyway, so chapter 8 starts on page 471. You also have the start of the chapter 9 lecture notes to work on. If you miss both of the Zoom classes this week, make sure you fill out the discussion board. On Tuesday, November 4th, you're going to want to have some candy. Okay, so uh, you're going to need to have around 5 ounces of M&Ms and 5 ounces of Skittles. Okay, so make sure you get those and have those ready to go for the Zoom session for the candy project. Um, Next week on Thursday, November 6th, we might be starting at a different time. So I'll message you on Remind, just give you a heads up on that. So I'll let you know if there's any issues. But for today, the Chapter 8 review, as I said, that starts on page 471. Okay. And um, so fill in the table with the appropriate symbols. So usually when you have a population, we're trying to measure either a mean or a proportion. So an example would be if I wanted to know the average weight of the people in America, um, that would be a mean. And the population is everyone in America, and I can't do that. I can't weigh every single person. Okay, there's hundreds of millions of people. So I would take a sample, look at that mean, okay, and then that would be a very close estimate for what the population mean is. Okay. Um, or you might be looking at our proportion. So maybe I would say, what percent of people in America have used public transportation or have a driver's license, right? So in that case, my answer is a percent, and again, my entire population I can't measure, so I would do a sample. Okay. Um, so as long as you meet the criteria for the central limit theorem, you can treat the sample distribution as a normal distribution. Okay, that's what the central limit theorem says. Okay, um, so one of the requirements for the central limit theorem is that your sample is big enough. Okay, so we messed around with that in our Chapter 8 project. And as you get larger and larger sample sizes, it gets closer and closer to a normal shape. Okay, um, so for this question number 2, the following 3 distributions are of sampling distributions of sample means with 250 samples taken with 3 different sample sizes. Okay, that sounds just confusing. For question 2, one of these, the sample size n is 5, one of them is 10, and one of them is 20. Okay, so how do I know which one is which? So part B is asking, explain how you can tell which graph is associated with which sample size. So a larger sample size means a smaller spread. So when we talk about spread, we're talking about the graph here, how wide it is. A small spread is going to be narrow, it's going to be skinny and tall. Okay. So larger sample size means a smaller spread. All right, we'll come back to that um, in a bit. Okay, let's move on to the next page, page 472. Can you guys still see my screen?
Yes.
All right, great. Question three, a sports analyst gathers a random sample of NBA players from the season and records the number of games that they played. So here are your statistics. Calculate the standard error of the sample mean. So the standard error of the sample mean, no, I did not write a bad word. It's the standard error of the sample mean. I know it looks like a bad word. So the formula for that is your standard deviation divided by the square root of n. And you can find that on page 184. Okay. Page 184 is where the central limit theorem is, and it's this bottom one here. Standard error, that's the spread of your distribution, and it's the standard deviation divided by the square root of the sample size. Now, here it shows sigma over square root of n, and here it shows s over the square root of n. Sigma is the population standard deviation. S is the sample standard deviation. So how do I know which one I should use? Well, the answer is whatever standard deviation you have. Um, when you're doing these problems, you are not going to have both. If you know the population standard deviation, then there's no reason to take a sample. The whole reason we do samples is because you can't measure the population. Okay. So anyway, uh, S divided by square root of n. All right. Question four. The average BMI for adults in the US is 30, with a standard deviation of 6. A weight loss researcher gathers a sample of 72 random US adults. There are 250 million US adults, or 250 million adults in the US. Verify that the conditions of the central limit theorem for means are met. Okay. So in order to use the central limit theorem, we have to verify that we've met the conditions. Just like if we were trying to use the Pythagorean theorem, we would have to check and make sure that our triangle was a right triangle. Okay. So the conditions that we have for the central limit theorem are random, independent, and normal. Okay. Or in other words, is your sample size big enough? So random, independent, and normal. Okay. So first of all, random. Um, did for the class, we just have to check and make sure that the word random is somewhere in the question. And it is. They said that we did a random sample of 72 people. So yes, it's given in the problem. Okay. Now in practice, random is actually the hardest of the conditions to check because or to make sure that it's true because doing a random sample is not easy. Okay. We've talked about that already. Um, but in the class, all you have to do is check and make sure the word random's in there. Okay, so that's the easy one. Now, in reality, in real life, independent is the easiest one to check. Independent, you need to make sure that your sample is independent of the population, which just means your sample can't be too large. Okay, so for that, we need to check n is less than 5% of the population size. Your sample size is 5% of the population size or less. Okay. So to check this, our sample size was 72, 5%, and our population was, okay, so our sample was 72 random US adults. Our population is all US adults, so that would be 250 million. Okay. So the question is 72 less than 5% of 250 million? So can someone do 5% of 250 for me? 0.05 times 250. What do you get?
12.5.
12.5 million. So in other words, 12,500,000. Is 72 less than 12 million? Yes, it absolutely, right? So for independent, um, it's easy to make sure that your population's not too big. Um, so yeah, so the last one, normal, is just checking to make sure your sample is large enough. And for the central limit theorem for means, we just have to check and make sure that the sample size is larger than 30. Okay. For the central limit theorem for proportions, this last condition is a little bit different, but it's still checking to make sure your sample is large enough. So we need to check if n is greater than or equal to 30, and in our case, 72 is indeed greater than 30, so yes. Okay. Three yeses means that yes, we checked and the conditions for the central limit theorem are met. Okay, so that means we can use the central limit theorem. By the way, this one right here for independent, um, the formula 0.05 times n for independent, um, you can do it this way, but so 5% is the same as 1 over 20. So if you multiply both sides by 20, you get 20n is less than capital N. You can use either one of these formulas when you're checking independent, okay? Sometimes this one will be a little bit easier because you might not necessarily know what the population size is, okay? So we'll see that on page 4, okay? So either one of those is good. All right. For part B, now that we uh, know that the conditions are met, we can describe the sampling distribution. So we want to talk about the shape, the center, and the spread. Okay. So the shape of your distribution will be normal, approximately a normal distribution. Okay. The center will be whatever your mean is. Okay. In other words, you can use the sample mean as an approximation for population mean. And lastly, the spread, we already did that one. SEX is square root of, is the standard deviation divided by the square root of n. Okay. So your shape is normal. Your center is whatever your mean is. And they told us the mean, in this case, for question 4, the average BMI for adults is 30.7. Our units were kilograms per meter squared, whatever that means. Okay. And our spread is going to be standard error of the means equals S over the square root of N. The standard deviation they gave us was 6.1. And the sample size is 72. So let's put that in, see what we get. All right, so 6.1 divided by the divide button is your question mark button on your keyboard. You just don't hold the shift key. And then square root, you type SQRT, and that'll give you the square root symbol. SQRT squirt 72, and I get standard error of 0.7189. Okay. Units for that were kilograms per meter square. All right. Page 473, question 5. The following three distributions of the sampling distribution, 1,000 samples taken, three different sample sizes. Okay, so this is the same as question number 2. The only difference is instead of measuring a mean, we're measuring a proportion. Okay, but a lot of the same stuff is true. And that's why we kind of grouped both of these into the same chapter, means and proportions, because a lot of them are the same steps. So larger sample size means a smaller spread. Okay. And vice versa, a smaller sample size means a larger spread. Okay. So not really too much to talk about there. So I'm going to, I think that's all the hints on that page. So we're going to go to page 474. And on our last page, so compute standard error of p hat, which is the proportion. So that's on page 189. So page 189 is more central limit theorem stuff, but this time for proportions. And the standard error of the proportion is square root of p times q over n. Big square root p times q over n. Okay. Now, this calculation is actually the same as the one for means, standard deviation divided by the square root of n. It's just that the standard deviation when you have proportions is the square root of p times q. So to save us a little bit of time, we just have a separate formula. Okay. These formulas, by the way, are not in your uh, exam notes packet. So you're going to want to make sure you have those written down um, in your 8.5 by 11 piece of paper for the final exam. You'll see like things related to them in chapter 9, where we will use that standard error number. Okay. Anyway, lastly, question 7. Study found that 39.5% of U.S. teens have a driver's license, random sample, 224 U.S. teens. Verify the conditions of the central limit theorem are met. So it's the same thing. We want to make sure it's random. Need a random sample, independent, and normal. Okay. These first two are going to be the same. The last one down here is a little bit different. You're not going to check if n is bigger than 30. You're going to check if n times p times q, if that's bigger than 10. Okay. Because if you just have a sample size of 30, but your proportion is very small, like if your p was super tiny, like 1% or less, then 1% of 30 is only 3. And that's not enough information to be able to make informed business decisions on. Okay. Or informed medical decisions, I guess. My job's related to business. So anyway, describe the sampling distribution. We describe the shape. We describe the center and spread. Okay. All right. All right. So that's all the hints I'm going to give you on Chapter 8 review. Let's jump back to page 471 and go through the questions together, and we'll fill in the answers we skipped.